Okay, so today what we're going over is graphing functions. Today we're going to be using something called a function table to help us do that. How many of you guys have used a function table before? Raise your hand. You think you might have used one before? Okay, a function table. Yeah, okay. All right, so here's what we're going to be doing, okay? One of the things we're going to be doing is graphing using a given domain. Okay, so the first example we're doing today is graphing using a given domain. Okay, this is when we're given a certain domain, so they've given us a set of values for x. Okay, so for our first example, we're going to graph this function f of x equals negative 1x plus 2 for these domain values. And the domain values are these: negative 1, 0, 2, and 5. Alright, so here's how we're going to do that. We're going to use something called a function table. Okay? So I'm going to make a column in my table for my x's. I'm going to make a column to do a little bit of scratch work where I plug the number into the function. I'm going to make a column for my y values, or my f of x values. And then I'm going to make a column last for the ordered pair that I'm going to graph. Okay, so what I'm going to plug in right here in this column is I'm going to use all of these x values they gave me. So I'm going to use negative 1, 0, 2, and 5 in my x column. I'm getting those numbers from the specific domain that the problem stated in the beginning. Okay, now what am I going to do with each of those values? Well, I'm going to take each value and put it in the spot for x and see what this function makes when, for example, x is negative 1. So when x is negative 1, this function says negative 1 times the x value of negative 1 plus 2. Okay, well, what is negative 1 times negative 1?
1.
Positive 1. And what's positive 1 plus 2? 3. So my ordered pair that I'm going to put on my graph in just a moment is going to be negative 1, 3. Okay, this is the x value. This is the f of x value. Now we would do this the same way if instead of f of x it said y right here. Have you guys ever seen, you guys have seen it before where it says y equals something? Okay, so if we had y, we would have y up here and this would be x and y values, right? Okay, so now let's do for 0. So when I have 0, I still have negative 1 in front here, right? Because that's part of the function. But instead of x, now I'm putting 0 there. Okay? So I have negative 1 times 0 plus 2. Well, negative 1 times 0 is 0, and 0 plus 2 is 2. So here's my next ordered pair, 0, 2. And I'm going to put that on the graph in a little bit. Okay. All right. So now next I'm going to do negative 1 times, now my new x value is 2. So I'm going to put 2 in the place for x. Okay. So what's negative 1 times positive 2?
Negative 2.
Negative 2. And what's negative 2 plus 2? 0. So my next ordered pair is 2, 0. Right? So I have 2 and 0. Okay. All right, and then last, I'm doing negative 1 times 5 plus 2. So that makes negative 5 plus 2. What's negative 5 plus 2? Yeah, negative 3. So here's my last ordered pair, 5 comma negative 3. Now, what do I do after this? Well, now I want to graph. So I gave you guys some small graphs to use, right? Okay, so go ahead and cut out one of your small graphs that I gave you. And you're going to glue it on. And then we're going to graph those points. Okay, so now we're going to graph each of these ordered pairs onto the graph. So negative 1 comma 3, that's to the left 1 up 3 spaces, right? Then 0 comma 2, that's over 0 up 2. 2 comma 0 means over 2 to the right, up 0. And then 5 negative 3 means 5 to the right, down 3. Okay, now, I've gone ahead and I've graphed these points, right? This is what it should look like. So, because they gave me a specific domain, this graph is what we call discrete, right? We talked about this today when we were going over homework, right? When I write the domain for a discrete graph, I write it as individual points, okay? So, when the domain is given as individual points, the graph is discrete. Okay, what does it mean when the graph is discrete? Is it dotted or is it connected? Dotted. So, do I get to connect those dots? No. Okay? Do not connect the dots. Okay? When they've given you a specific domain that is just a few points, it means it's discrete. We're not connecting. Okay? Not connecting. Okay, now we're going to take a look at an example where we're going to graph using the domain of all real numbers. Okay, when you're given a domain of all real numbers, they didn't give you like a set where you just had 3 or 4 numbers, right? They said it could be any number, all real numbers, right? This means it could be a fraction, it could be a decimal, it could be anything. It could be a really big number, a really big small number. It could be any numbers, right? So this is where we're going to eventually get to connect the dots, okay? We're also going to get to have this function, instead of being discrete, be continuous, because we can use all the numbers in between any points, okay? So we're going to graph for our first example this one, okay? And it is f of x equals 2x minus 1, okay? Now, we don't know what points to put, because last time they gave me some certain values, right? They gave me like negative 1 and 2 and 0 and 5, whatever they gave me, right? This time they just said the domain's all real numbers, so I could pick any numbers. Now, even though I could pick any numbers, does that mean I want to go nuts and pick like some really big crazy numbers? Or like maybe my lucky number is 72, so I want to pick 72? Probably not, okay? The reason why is when you're graphing these values, you want to graph something that could potentially reasonably end up on your graph. Now the graph I gave you looks like this, right? And if you look, how far are these numbers going on this graph? Up to 8. So if you pick 10 to start with, your x value is automatically off your graph, right? So probably not the best choice. Also, the bigger numbers you pick, the more difficult they are to work with when you start multiplying them and dividing them and adding them and subtracting them. So let's pick some numbers that are smaller and a little more reasonable?
3.5.
Okay. Would I want to use, someone just said 3.5. Do you guys want to work with a fraction if you don't have to?
No.
I don't want to pick a fraction.
3.
Maybe you love fractions. Okay, but I don't like working with them particularly. All right, so I think for me, this is just the system I use, and it works for me usually, okay? I usually pick a couple negatives, a couple positives, and I pick 0. And I pick the smallest numbers that I could work with, so I like to pick these numbers. These are my numbers that I normally pick. I usually pick those numbers unless there's some compelling reason why I shouldn't use them that I'm seeing when I'm looking at the function. But when I'm looking at this function, there's no reason that's telling me I shouldn't use those numbers. And we'll talk about like later on when we get to more complicated things why I might want to pick not those numbers, okay? But for right now, these numbers are fine. So let's go ahead and plug them in. 2 times negative 2 minus 1. I'm plugging into this spot right here for my x value, right? So what's 2 times negative 2? Negative 4 minus 1 is what? Negative 5. So now here's my first ordered pair. Negative 2, negative 5. Okay? So I'm going to keep doing that for each x value I chose. The next x value I chose was negative 1. So 2 times negative 1, negative 2. Negative 2 minus 1 is negative 3. So here's my next ordered pair. Okay, then I'm going to go ahead and plug in 0. And I get 0 minus 1. What's 0 minus 1? Negative 1. So here's my ordered pair, 0, negative 1. Now I'm going to plug in 1 for my value, so 2 times 1 minus 1. Well, that's 2, take away 1. What does that give me? 1. Okay, and here's my very last one. 2 times 2 minus 1. That's 4 minus 1. What's 4 minus 1? 3. Okay. So here are my values. Okay, so now I'm going to have you guys take another one of your graphs, cut it out, and we're going to glue it on and graph those points. All right, so let's go ahead and graph each ordered pair. So negative 2, negative 5, it's down there. Okay, negative 1, negative 3. Okay, 0, negative 1. And 1, 1, which is over 1, up 1. And then 2, 3, so over 2, up 3. Okay, now, we discussed earlier how this function, since they gave us a domain of all reals, okay, when we have a domain of all reals, what did we say was going to happen with our function? It's going to be what? Continuous or discrete? Okay. The graph is continuous. So if the graph is continuous, what do I get to do with the dots? Yeah, connect the dots. So in this one, we are going to connect the dots. All right, now, when we connect the dots, we can actually connect them, and then we can draw little arrows on the end to show that this line is, in fact, continuing forever and ever in each direction, because I can keep picking bigger x values, and I can keep picking smaller y values, and it would extend this line farther and farther and farther. Okay? Does that make sense there?